Imagine that you live in a not-so-distant future, and the world is engulfed by massive famine, and due to this, society is tearing itself apart from the ground up. This apocalyptic scenario may seem like fiction to some, but this is actually a very likely event because the world's supply of fresh water for agriculture is dwindling due to the world's growing population. However, the alternate scenario of us not only surviving but even thriving, in the case of dwindling water, is even more likely due to developments in transgenic crops. A transgenic crop is a crop that is inserted with a certain gene from a different organism, maybe another plant or even an animal, and then it replicates that gene, and that gives it a new feature or function. In this case, genes that grant resistance or tolerance to drought can be inserted into crops, and that gives them the ability to be grown with less water. This is how we have the potential to survive and thrive in times of short water supply. So today I'd like to speak with you about why farmers will eventually transition to these types of crops. So I'd like to speak about the economics of why this is so, why the world's supply of water, why its state in the future will cause a transition to these crops, and why water reduction itself may be necessary in the future, and these crops may hold the solution. Alright, so first I'd like to speak economically about why these crops are beneficial. So as I mentioned, these crops can be grown with less water and have potentially a higher yield. For one example, in a study by Zvi Peleg, a member of the Department of Plant Sciences at the University of California, a certain gene termed isopentenyl transferase was inserted into a particular crop. This crop was compared to a control, or a crop that didn't have this gene. And this gene modified the crop structure to where its source, or its top two leaves, were enlarged, and its sink, or the vein or flower responsible for absorbing water, was also altered. And due to this, once these two crops were watered and compared to one another, the transgenic crop remained wetter for longer because it was absorbing water in a slower, more methodical manner. This more efficient use of water allowed it to be grown with less water, and while at the same time it had a higher yield than the control crop. And so by producing more with less, that greater cost efficiency shows why these crops can outcompete traditional crops, at least in terms of water. And this same principle can be applied by manipulating the ploidy, or chromosome levels of crops. Take wheat, for example. Wheat is hexaploid, or it has 6 times the number of monologue chromosomes. And due to this, it has a much higher grain yield and what's called water use efficiency than plants it evolved from, or other modern plants. In studies by Professor Zhang Zhengbin from the Key Laboratory of Agricultural Water Resources at the China Academy of Science, he's proved that ploidy levels are also representative of water use efficiency by inserting genes to heighten chromosomes. He's also proved that these crops that result from this have higher grain yields and higher water use efficiencies. So again, by producing more with less, that's how these crops are more economically competitive than traditional crops in terms of water. However, not only will the water-saving effects of these crops make them desirable in the future, but also the state of the world's water supply itself. The world's limited freshwater supply, it's severely divided by different competing interests. For agriculture alone, it's used for irrigation, livestock production, fisheries, the works. For everyday uses, it's used for things like consumption and sanitation, and even in industrial purposes like hydropower, for example. And so this sharp divide calls for the need for efficient water resources. And so, if the world's population continues growing in the manner it has been in the future, then this divide will become even sharper and create the need for even greater water use efficiency. And so these crops can provide the solution to that because they require less water. Also, consequently, because of this sharp divide and this competition, the manner in which water is obtained for agriculture can sometimes be detrimental. In some cases, water for agriculture is obtained through the use of altered flow regimes. An altered flow regime is take a dam or a bridge or some water engineering project that diverts the flow of water from its natural source to a site of agriculture. However, these natural bodies of water are already natural habitats to different organisms. And so by altering these habitats, you're potentially harming or even killing off these organisms. And that can result in a lack of biodiversity or diversity of organisms. And this can result in a degraded water quality, which can have adverse effects if that's used for irrigation for crops. It can also result in a lack of raw materials for different medicines, or even in worse cases, can lead to the transmission of waterborne diseases. And so this is where crops may come in handy in the future. If these pressures on farmers by others become that much stronger due to environmental concerns, these crops may provide the solution because less water lessens the need for these altered flow regimes. Furthermore, reduction of water itself may be necessary in the future for agriculture due to negative effects it may have on the environment through erosion or the degradation of soil. Erosion itself is already a serious factor. For example, here in the United States alone, there are 472 million acres of arable or farmable soil. And of this amount, tens of millions of tons of soil are lost each year due to erosion. One of the more dire years was from 1973 to 1974. 47 million tons of soil were removed due to water erosion alone, in large part due to irrigation. And so in the future, if the world's population continues growing the way it has been, then no greater methods of water use efficiency have been developed, then water may be forcefully redirected towards agriculture. And along all the other negative effects this may have, it could lead to even greater feats of erosion that may even inhibit agriculture and our ability to supply our own population with food adequately. And so by using these crops, which require less water, that's another step in the right direction. And finally, the cost of potentially restoring the soil may also provide this incentive to use these crops, because there are methods for restoring or preserving the soil that have greatly improved over the decades, like crop rotation, planting crops in the same area in different seasons to restore the soil, or even removing the soil, as we mentioned earlier, with heavy machinery in many cases. While crop rotation is an absolute necessity, it will probably never be eliminated. The use of heavy machinery may be eliminated to a degree, because if these water-efficient crops are used, it may reduce erosion to a degree to where it reduces these processes, and therefore it reduces the cost to those growing these crops. So that's another economic incentive for using these crops. So as a recap, farmers are likely to transition to these crops in the future due to their water-saving effects, competition over water resources, and the possible need to reduce water usage in the future due to negative effects it may have on the environment. These types of transgenic crops aren't in widespread use yet, but when they are, I have no doubt that because of them in the future, will not only survive, but even thrive in the case of limited water supplies. Thank you.